Welcome back. Problem 8-33. And this problem is taken from Mechanics of Material by R.C. Hibbeler and it's chapter number 8, Combined Loading. The statement of problem is control lever is subjected to horizontal force of 20 Newton on the handle. Determine the state of stress at point A and B. Sketch this result on differential element located at each of these points. The assembly is pin connected at C and attached to a cable D. So you can see from this figure, this is the control lever that is subjected to horizontal force of 20 pounds. That point C is pin connected and there is a cable D that is acting. So due to this force, the cable this element exert force on cable in this direction. As a result, force exerted by the cable on this element will be in this direction. So what we will do is that if you draw the free body diagram, I will draw the free body diagram by using the part as red color. So this is the lever. You can draw it separately. This is 20 pound force. So if you remove this pin connection at point C, so there will be a vertical force which is Cy and there will be a horizontal force which is represented as Cx, and the cable will exert since this will due to this the cable will be in tension. As a result, this force will exert a force downward on the cable. So this will be the F. Let this force is represented as F, or you can see P because there is a point F as well. So what we will do is we will find this force P by using equation of equilibrium, that sum of all moment about point C must be equal to 0, taking the counterclockwise moment as positive. Why point C is taken? Because if we take point C, a moment, sum of all moment about point C equal to 0, so this force will pass through this point and it is not producing moment. So we will only left with this P and this force. So 20 into perpendicular distance, this is 20 and the perpendicular distance about C is 5, and this is producing clockwise, so it will be negative. So minus 20 into 5. The second moment is produced due to this force P and perpendicular distance is, you can see, 0.5 plus 1.75, which is 2.50. And this is producing counterclockwise movement, so it will be positive. So I will write plus P into 2.50 will be equal to 0. So 2.50 into P is equal to 100. So you will get P will be equal to 40 pounds. Now you have this P. So what we will do is that again the first portion determine the state of stress at point A and B. So B point is there. So if you cut this lever at this point, the cross section is shown over here. So if we cut at this point, we will choose another color and draw the free body diagram. So this is the lever. Okay. So the horizontal force is 20 pounds. Distance is shown as 2 inch. So from here the distance is 2 inch. And when you cut it, you will be having a shear force V and you will be having a moment which will be in this direction. So we'll find this moment and shear force. So for shear force, sum of all force along x direction must be equal to 0 and force in this direction is taken as positive. So 20 minus V will be equal to 0. So from here shear force is equal to 20 pounds. What about movement? So for movement we will find sum of all movement about, let this is your point number 1, about point 1 is equal to 0 and taking the clockwise movement as counterclockwise movement as positive. So one movement which is counterclockwise is M, and the second movement about this point 1 is 20 into 4, which is clockwise. So I will write M minus 20 into 4 is equal to 0. So M will be equal to 80. Okay. 20 into 2. Sorry, not 4. This is 2 inch. So 20 into 2, which is equal to 40 pounds into inch. Now you can see you have movement and shear force at this point. So we know that bending stress at point B, if I draw this lever over here in 3-dimensional, so this will be like this. There, this is your point BE and this is your point B. And this will be, since you can see the bending moment will be like this one. So if this is the neutral axis, so you can see the upper portion above this will bend like this. So point B will be in compression. We know that bending stress B is equal to minus M into Y divided by I. Clear? So minus 40 Y. What is Y? Y distance from neutral axis till point B. And this distance is given as, this is 0.3. So this distance is 0.15. This distance is 3. So this is 0.15. So 0.15 divided by I. I we will calculate for this cross section 0 by 3 by 0.3 inch. So this is square, so it will be 1 over 12. B is 0.3 and height is 0.3 whole cube. And you will get I is 0.675 into 10 raised to power minus 3 inch power 4. So you just put the value 0.65 into 10 raised to power minus 3. So you will get bending stress will be equal to 8.89 minus, and the unit will be KSI. So sigma B will be equal to 8.89 KSI, and this is in compression. Okay. Now we will move toward our second part. Since you can see this was your point E and this was your point B, and this was the neutral axis. So we know that shear force is equal to V into Q. Since point is B, so VB QB divided by I into T. And Q, we know that QB is equal to Y dash bar into A dash. Since this point lies on outside boundary, so there is no area above it. So A dash will be equal to 0. It means that QB is equal to 0. So since QB is equal to 0, it means that shear stress will be also, shear stress at B will be 0. So I will write shear stress at point B is equal to 0. Clear? Since QB is equal to 0. Now we'll move towards second part to find out the shear stress and bending stress at point F. So what we will do is that we will cut it over here, somewhere here, and draw the free body diagram. So let me draw it. This is point D, where you have a load of P that is acting, and when you cut it at distance, so you will be having a shear force and you will be having a movement in this direction. And this distance from this till this distance is, you can see that this is 0.75 inch. So we will find the vertical force, sum of all forces along this direction, which is, this is your Y dash, this is your X dash. So Y dash will be equal to 0, taking the force in this direction is positive. So P is 40 kilonewton, which is minus downward minus 40 plus minus 40 and uh, minus V is equal to 0. So from here V is equal to minus 40 pounds. The value is minus, it means that we have taken V as downward, but V is negative, so it means that our the direction of V is upward. Direction of shear force is upward. Okay, now we will find moment as well. So sum of all the moment about, let's say this is the point 2, about point 2 is equal to 0, taking the counterclockwise movement as positive. So one moment is this one, which is clockwise, this is negative, and the second moment is P into perpendicular distance is 0.75, this is counterclockwise, so it will be positive. So minus M plus P, which is 40 into 0.75, is equal to 0. So we will get M will be equal to 30 pounds into inch. Now you have shear force and moment as well as. So what we will do is that you can see at here this section, the cross section is shown, which is 0.25 and the height is 1 inch, 0.5 and 0.5, 1 inch. So what I will draw it. This is the triangle. Let me draw it correctly. So this is 0.25 inch and total height is 1 inch. So neutral axis will be 0.5 inch and this is 0.5 inch. Now point A is at this point. Clear? So this is your point A. Again, we know that bending stress at A is equal to sigma M minus M into Y divided by I. Clear? And you can see that bending stress at here is like this. So it means that upper surface will be in tension. Clear? You can also write it upper surface is in tension and the lower one will be in compression, so point A. So you can also, instead of, you can write it as stress at point A is M into C divided by I, and this will be in tension because upper portion is in tension. From here you can see upper portion will be in tension. Okay, so you can just put the value 30 into C is distance from neutral axis till top, which is 0.5. Clear? And divide by I, which we have calculated, or we will calculate for this one. I will be equal to 1 over 12. B is 0.25 and height is 1 cube. So I will be equal to 0.020833 inch power 4. So put it over here. So you will get 720 psi and this will be in tension. Let me show you, I have also written over here this formula minus M into Y. So you can see that at this point E, you can see that this was the moment there. So upper portion was in compression, the upper was in, let me check it, wait a minute. The moment you can see here is this one. This was like this, so not like this. Let me check. So movement was like this. So that will cause compression at point B. That's why if you take sigma B is m into c divided by I, but since this point will be is in this point B is in compression, this point B is in compression, so you can see this stress will be in compression. Okay, so now we'll find shearing stress at point A, and again this will be equal to 0 since QA will be equal to 0. You can check that this is point A, so the area about A is not available, so we know that QA is equal to y dash bar into A dash. So A dash is equal to 0 because at above the point A there is no area, so QA will be equal to 0. So QA is equal to 0, so tau A will be equal to 0. Now we will define the state of stress at point B and E. So for point B, if you take the element, so only stress is sigma B, which is compression, so minus 8, so it will be like this one. This will be sigma B at point B, and that is sigma was 8.89 KSI. Now for point another point, that is for point A. For point A, if I draw the state of stress element like this, clear? So you can see this is in tension, so it will be like this. There is no shear force, so it will be sigma A will be equal to 720 psi. So this is the sketch, the result on differential element, and these are the stresses at point A, shear stress and normal stress, and this is the normal stress and shear stress at point B. And that was all about this problem 8-33. I hope you have enjoyed this video and you have learned it. Also remember that I have attached all the links of my playlist in description box, that is arranged chapter wise, so you can also find my videos in the description box as well. If you have any question, you can ask me in comment section. Thank you for watching.